Today we're going to continue talking about quadrilaterals. In particular, we're going to talk about special parallelograms, rhombuses, and squares. And we're going to see what additional qualities they have that make them more than just a plain old parallelogram. So parallelograms, remember that opposite sides have to be parallel and congruent. Opposite angles have to be, both pairs of opposite angles have to be congruent. And your consecutive interior angles or your same side interior angles have to be supplementary. So then let's look at what happens. So all of those properties happen to create a parallelogram. So that's what makes it a parallelogram. But then additionally, and this is what is important, is all the sides are congruent. When all of the sides are congruent, meaning that AD is congruent to AB, is congruent to BC, is congruent to CD, all of those sides congruent. Now, when all of those sides are congruent, it causes these two other things to happen. Okay. Now remember that the diagonals of a parallelogram bisect each other, and that still happens here. These two have been bisected. Not only do the diagonals bisect each other, so we know this right here, in all addition to the other things, but since we're going to talk about the diagonals, I want to point that out. The diagonals are bisected. They're not congruent to each other, but they are bisected. They also bisect the angles. What makes that nice is that we have a lot of congruent angles. That BD bisects angle ADC. So this angle is congruent to this angle. That also means, since these opposite angles have to be congruent, that those two angles are congruent also. So all four of these angles are congruent to each other. We also have the opposite. These two whole angles are congruent to each other. Angle A is congruent to angle C, but this diagonal AC also bisects these two angles. So those four angles are all congruent to each other. So that's one thing that happens. The diagonals are bisected. They bisect each other. They bisect the angles. And the other really, really important thing about what the diagonals do is that they are perpendicular. Because the four sides are congruent, it means that all four angles in the middle of that rhombus are congruent, which means they are 90 degrees. They're all linear pairs, right? And they're all vertical, but they're all 90 degrees. They're all perpendicular. So the first thing, as soon as you see that all four sides are congruent, the first thing you want to do is go in and mark that those diagonals are perpendicular, because that's going to give you some hints about how to work the problem when you're finding angles. Okay, now that's a rhombus. Now let's go even more special. A square is a parallelogram, opposite sides congruent, opposite angles congruent, diagonals bisect each other, same side interior angles are supplementary. It has all the qualities of being a rhombus, so everything we just talked about, the sides are all congruent, so we know that about a square. All four sides are congruent. The diagonals bisect the opposite angles, so these are congruent, these are congruent. The diagonals are perpendicular to each other. Those things happen because it's a rhombus. And then don't forget all of the qualities of being a rectangle. Because it's a rectangle, these angles are all 90 degrees. So they've been bisected and they're all 90 degrees. Now what that tells us, which makes squares really nice, is that every single angle in the corner has been bisected to be 45-degree angle. So for a square, only for a square, are they all 45 degrees. The other thing that happens is that AC is congruent to BD. Remember that when all four angles are right angles, it causes the diagonals to be congruent to each other. When all four sides are congruent, it causes the diagonals to bisect the angles and the diagonals to be perpendicular. Okay, so the congruency causes these two things to happen, and the angles being right angles cause those diagonals to be congruent additionally. Okay, so let's look at some problems that have to do with this. We're looking at angles, so let's think about the things that we know about the angles of a rhombus. We go back up here. We know all the things about being a parallelogram, but let's start with the things that are special about being a rhombus. The diagonals bisect the opposite angles. And so when you look at this problem, right, the diagonals bisect the angles. Let's just kind of write that down so we keep that in mind. The diagonals bisect the angles. So when you look at this, we have to figure out where to start. That starts right here, this 34. Well, this whole angle has been bisected by that diagonal, which means that angle 1 is also 34 degrees. These opposite angles are congruent. That's the parallelogram issue, right? That's the property of the parallelogram. So that means that both of these are 34. I'm going to fill in that one even though I don't need it just yet. So then I stop and I look for a minute and I figure out what else I know. Well, the other thing that I know is that the diagonals are perpendicular. Perpendicular means that they are 90 degrees. That means all of these angles are 90 degrees, which means that angle 2 is 90 degrees. Now, when you look at that, what I want you to see when you're looking at this rhombus is you have 1, 2, 3, 4 right triangles. The angles of a triangle, the interior angles of a triangle add up to 180 degrees. So in order to find, I need to get to a missing angle. So let's get over here to angle 3. It doesn't matter where you go from there, but if you add up 90 plus 34, you get 124, and if you subtract that, now you don't have to do 180, you could just do 90 degrees and just subtract 34 from 90 degrees. You don't have to add them all up, but if you don't recognize that 90-degree angle as part of that, then you might be thinking the 180. So 180 minus 24 is 124, excuse me, 180 minus 124 is 56. Now, notice 56 and 34 right here is 90 degrees, right? The acute angles of a right triangle have to be complementary. They have to add up to 90. So now that we know one of them, again, we know that the diagonal bisects the angles, which means that 3 and 4 are congruent. And then that also means that 6 is congruent, and this angle over here is also 56. Now you have to be really careful because at this point you're going to want to go backwards and do this same thing with rectangles and parallelograms. This does not apply, right? These two angles are not congruent when you're talking about rectangles and parallelograms. Only with rhombuses and squares. So be careful. Don't go backwards and apply these same properties up that flowchart. So now we can go in and fill in all of our gaps. We have angle 1 is 34 degrees, angle 2 is 90 degrees, angle 3 is 56. You can certainly solve these in order, but you don't have to. Angle 4 is also 56. Angle 5 is 34 degrees. Angle 6 is 56 degrees. And then angle WZY has its vertex right here, and it's these two sides, is 34 plus 34, which is 68 degrees. Okay, so angles are bisected and diagonals are perpendicular. Okay, so let's look at this one. Again, JKLM. JKLM is a rhombus. So think about what that means. All 4 sides are congruent. That causes the diagonals to be perpendicular and the diagonals to bisect the angles. JL is 22. So JL is 22. This whole thing is 22. And MK is 18. Now, here's what's important. Let's look at what we're asking for. I want JN. Well, JL is 22. Now, remember, because it is a parallelogram, the diagonals bisect each other. Let's write that down so we don't forget. The diagonals bisect each other because it's a parallelogram. That means that JN is 11 and NL is 11. We can use that same thing, anticipating what may be coming next, that MK is 18, which means this is 9 and this is 9. So we've got that JN is 11, MN is 9, JM is the next piece that I need. So how can I find, I want JM and ML. Well, they're going to be the same because this is a rhombus and all 4 sides are the same. So I need to find that piece right there. So I have to think, okay, how can I find that? How can I find the sides? Well, Here's something that's important is don't forget the diagonals are perpendicular. When all four sides are congruent, the four angles are right angles. They're perpendicular. Now the reason why that's helpful is notice that right here it creates this nice little right triangle, one of our favorite tools to use. So I have two sides of the right triangle, which means I can use Pythagorean theorem to find the third side. So 11 squared, a squared, plus b squared is equal to c squared. Jm is the hypotenuse. So you would take 11 squared plus 9 squared. So 121 plus 81 is 202. So 202 is c squared. You need to do the inverse so that you can see that c is the square root of 202. And it says to round to the nearest tenth. So that's 14.2. It's 14.21 tenths place. Look one number behind. The 1 does not move the 2, so we say 14.2. So Jm is 14.2 and ML is 14.2. Okay. CDEF. CDEF is a rhombus. That means all four sides are the same. That means the diagonals bisect the angles. That means the diagonals are perpendicular. All of those things, right? So it says to solve for x and find the measure of angle CFE. So we look right here and we see, okay, we've got this angle and this angle. Well, we know that this diagonal bisects the angle. The diagonal bisects the angles. What that means is these two angles have been, this one big angle, CFE, has been bisected, and that means these two are congruent. Part equals part. So 5x plus 1 is equal to 8x minus 20. From there, we do the algebra. Subtract 5x from both sides, add 20 to both sides. You get 21 is equal to 3x, or x is equal to 7. Now I want the measure of angle CFE. In order to find the measure of CFE, there's my vertex, there's my angle, right here, I want that. So in order to find that, though, I need one of these two pieces. It doesn't matter which one you do because they're both equal to each other. 5 times 7 plus 1 is 36. This is 36, this bisected, so this is also 36, which means the angle CFE is 72 degrees. Okay? Then lastly, PQRS is a square. Instantly, you need to be thinking about this. It's the simplest quality of a square, but it's the one that we tend to forget to put that 90 degrees in the corner. And TR is 17, this piece right here. So the square takes on everything. It has picked up every quality from everything above it. And so let's start figuring out what we need. So angle PSR, my vertex is here at S, so I want that. That's easy enough. That's 90 degrees. Angle 1. Angle 1 is right in here, so we have to know what it is. Well, since a square is also a rhombus and all four sides are the same, that means that those four angles in the middle are 90 degrees. So angle 1 is also 90 degrees. Now from here, we like all the rest of the angles because since all four sides are the same, the diagonals bisect the angles. So those 90-degree angles get cut in half. So those are 45 and 45. These are 45 and 45. So angle 2 is 45 degrees and angle 3 is 45 degrees. Now we're going to start talking about the sides. That's the angles. All of these angles, every piece of that is 45 degrees. So now let's talk about the segments. So on the segments, it says PR. Well, I knew that TR was 17. Remember that the diagonals bisect each other because it's a parallelogram, which means that PT is also 17. So that means that PR, the whole thing from P to R, is 34. QS is this other diagonal that goes this other direction. Because the angles have right angles, it's a rectangle, and rectangles have congruent diagonals. So that means that QS is the same as PR. Okay, then we need QT. Well, QT has to be half of the 34 because the diagonals were bisected, so QT is 17. PQ. So PQ is the only one that we haven't gotten to yet, the actual side lengths of the square. And actually you have two options here. You have two sides, so you can use You can use Pythagorean theorem, or you can, if you recognize that that's a 45, 45, 90 triangle, if this is our 45, 45, remember it's 1, 1, root 2, so this would be 17, 17, 17, root 2. So if you don't see that, that's okay. You could do 17 root 2, or you could do 17 squared plus 17 squared is equal to c squared. The square root of 17 squared plus 17 squared, you can type it in like that, you get 24.04, or 24.0 rounded to the nearest tenth. Now, just so you can see it, look at 17 root 2. The 17 times the square root of 2 is 24.0. So you get the same answer. It's just one is approximate and one is exact. Okay, so the differences between a square and a rhombus. The difference between a square and a rhombus is that a rhombus does not have the right angles in the corners at the vertices that the square does. Everything else is the same, but a rhombus has the congruent sides that a square has, but it does not have the right angles at the vertices. It just has that the diagonals are perpendicular, but not the sides are perpendicular. So that's the difference between them.